So in today's lecture, we're going to kind of finish up and conclude kind of all things decimal. So the first thing I want you to ask yourself is, how do you go back and forth between the forms, fractions, and decimals? And that's something we're going to expect our students to be able to do. And so we certainly need to know how to do it. All right, so let's talk about this way first. So how do you go from a fraction to a decimal? We'll just divide. Okay, going from a fraction to a decimal is typically the easier of the directions. Okay, you might need to remind yourself how to actually divide without a calculator, but at the elementary level you would not be using a calculator. Okay, so you would use regular long division. And then at the older levels, about 7th or 8th grade, they're allowed to start using the calculators. But going from a decimal to a fraction can sometimes be a little more challenging. So sometimes we can use place value. It's nice when we can do that. So for some of our easiest fractions, we're going to be able to just use place value. For instance, if we're asked to find the decimal equivalent of 1.35, that is 1 35 hundredths, right? Because the 5 is in the hundredths place, and then we would reduce. Okay, so all terminating decimals will work this way. So as long as the decimal ends, then kind of like we talked about last week, then we'll have no problem figuring out what place value we're in. So the more interesting question, though, is what about non-terminating decimals? What about those decimals that continue on forever and ever? Because we have some really common decimals that keep repeating. So let's take one that we know for sure. Hopefully, we know that 0.333, where the 3 just repeats. Okay. Hopefully, we know this is 1/3. But how would we show it? Okay. Notice place value is not sufficient to discuss a non-terminating decimal. And it's because the 0.333 goes on forever. It goes on forever and doesn't stop at any particular place value. So usually I have my students in my face-to-face classes kind of brainstorm this, because a lot of times we think about 1/3 as being maybe 3/10, right? Or maybe 33 hundredths, or maybe 333 thousandths. Notice this would be 0.3. Sorry, let me move that up. This would be 0.3, this would be 0.33, and then this would be 0.333. Okay, but none of those take care of a decimal that just doesn't end. So we have a method we can use to show this that I'm pretty sure y'all are going to just love. Who doesn't love algebra, right? But in all seriousness, you come from college algebra. To take this course, you have to have had college algebra. So this is certainly something you have talked about before, but admittedly it might have been a long time ago, so we're going to go through it step by step. So we're going to use what's called a system of equations. Systems of equations are where we have the same variables in multiple equations, and we use those equations together to find out the value of the variable. So I'm going to go through some steps, and then we're going to practice this on a few. So the first thing is, if you're trying to find out what the repeating decimal equals, we're trying to find out what fraction the repeating decimal is going to be the same as. So step one is you're just going to set your unknown equal to x. We don't know what the value of the fraction is for the repeating decimal, so we'll set that equal to x. Okay, this is probably the most important step in the method, so it takes a little explanation. So the second step is you're going to move the decimal enough places so that one set of repeaters so in other words, the things that are repeating are in front of the decimal place. And you're going to do that by multiplying by powers of 10. So in algebra, you're allowed to multiply both sides of the equation by anything you want as long as you do the same thing to both sides. So I'm going to underline this. We want one set of repeaters to be in front of the decimal place. And then step 3 is you're going to use what we call in algebra the addition or the elimination method. Depending on where you took your class or what book was used, these names are the same method. So you're going to use the elimination method to solve the system of equations. And then lastly, you're going to find x and simplify if needed. Okay, so let's practice on the repeating decimal that I mentioned that we kind of already know. So let's show that 0.3 with a bar over the 3 is truly equal to 1/3. Okay, so we're going to assume we don't already know that, and we're going to try to show that. All right, so I'm going to break these down with the steps that I called, or that I talked about earlier. Okay, so the first step is you're going to let x be your unknown. We don't know what the value of 0.3 repeating, okay, is, so we're going to call that x. So remember I put a star by step 2, it's the most important one. So remember what you're trying to get. I need to move the decimal place. So let's stop and think about that for a minute. Let's talk about how many places I'll need to move it. Okay, I need to be able to move one set of repeaters. Now notice there's only one digit repeating in this one. So I want to move 1 3 in front of the decimal place. Notice I only really need to move the decimal place one place to make that happen. So how do I move the decimal place one place? I multiply both sides by 10. Okay, multiplying both sides by 10 moves the decimal place one place. Okay, so let's take what I had originally. So I have x equals 0.3. So I want to move this repeater in front of the decimal place, so I'm going to multiply this side by 10, but in algebra I can't do that without also multiplying this side by 10. So notice what happens when I do that. I get 10x on the left. Okay, don't make that harder than it needs to be. When you multiply by 10, you just move the decimal place once. So this is going to be 3.3, but the 3's are still going to repeat. Notice one set of repeaters is now in front of the decimal place. So step 3 is you're going to line up what you got in step 2. And just for good measure, I'm going to write this out, that it's actually 3.333 forever and ever. And under that, I'm going to line up my original step 1, 0.333. Notice that the dots that I put there are actually significant, implying that this goes on forever and ever. So if we use the elimination method, we can actually add or subtract both sides of the equation as long as we do it correctly. So 10x minus x is 9x. Notice what happens nicely here. If I line all these up and I subtract, all of these are going to get canceled. Okay, so all the 0.3's are going to get canceled from both sides. And then 3 minus 0 is simply 3. And then last but not least, I just need to solve. So step 4 is I just need to basically solve. So I'm going to do it up here. I'm going to divide both sides by 9. So I get x equals 3/9. Just make sure that you can reduce fractions. So we would divide both by 3. And so in the end we get 1/3. Notice we showed, without acting like we already knew it, that 0.3 repeated actually is 1/2. All right, so let's take maybe some more challenging repeating decimals. So what if I asked you to convert 0.09 to a fraction? And maybe you already know what this one is, but we're going to assume that we don't know this one. Okay, let's run through our steps. So step 1 is whatever we don't know, we're going to set that equal to x. That's always what you do in algebra, right? When we don't know something, we call it x. Step 2 is you're going to need to think about this. I want one set of repeaters in front of the decimal place. So basically, I need to move the decimal. So think about that. Pause it if you need to. I would actually, one decimal place would not be enough, because then I'd still have a 0 in front. I really need a 0.9 in front. So notice what I'd really like to do is move it 2 places. Okay, so that means I'm going to need to multiply both sides by something else other than 10, but it's always going to be a power of 10. So what number would move the decimal place twice? 10 squared or 100? So again, let's start with what I had, 0.09 with a bar over it. So I'm going to need to multiply this by 100, and same to the left. When you multiply by a power of 10, you can kind of just think about however many zeros there are, that's how many times the decimal place will move. So you get 100x, and then if you move the decimal place twice, you're going to get 9, but the 0.09 will remain. So step 3. Now we're going to line up those two equations, the one we just got in step 2 and the one we started off with in step 1. So we've got 100x equals 9.090909. I like to show the ... and I like you to list out a few of the terms just so you can really see that we're actually going to get this to cancel out. And then let's line it up with the original. Make sure you line up the decimal point, 0.090909. Notice the reason this method is helpful is because it gets rid of the ugly part of the decimal, which is the repeater, right? It gets rid of every single repeating part. And then 100 minus x, or 100x minus x would be 99x. 9 minus 0 will just be 9. So you're almost there. Divide by 99. So in step 4, we just reduce if possible. So we get 9 over 99. And notice we could definitely divide both of those by 9. So in the end, we get that 0.09 repeated is actually 1/11. Okay, we actually talked about that in another video lecture, but I'm just going to assume we didn't necessarily memorize that one. All right, so I want you to pause the video and I want you to try one on your own. I want you to try to convert 2.18 with a bar over 1/8 to a fraction. Okay, so pause the video and see if you can do that one using the method that I just showed you. So that one looks like we're going to let x equal our unknown. Okay, again, I have a two-digit repeater, so I'm going to need to move the decimal place twice. So multiply by 100. So take your original. Notice I always kind of leave myself room here just because I kind of need room to multiply by whatever I'm going to multiply by. So I'm going to multiply by 100. So that's going to give me 100x on the left. And then if I move that decimal place twice, it's going to be 218. But then the 1/8 is still going to continue to repeat. So as long as you do step number 2 right, step number 3 should always kind of line up. So we're going to take this repeating decimal, right? 181818. And we're going to line up the original, which was 2.181818. Notice it's really important, I've already mentioned this, to make sure that you line up the decimal place so that you get this nice cancellation. So here we get 99x equals 216, because 218 take away 2 is just 216. And so last but not least, we can divide by 99. So step 4, we get x equals 216 over 99. But then we can divide by 9. So notice we end up getting 24 over 11 here. We get it what we call an improper fraction where the top is bigger than the bottom. And we expected that because if you look back at the very original, it was 2 point something. So the question is, what is it going to be? So if you've forgotten how to do this, you can divide 22 by 11. Notice 11 goes into 24 by 11. 11 goes into 24 twice, right? 2 times 11 is 22. And whatever your remainder is here, that's what's going to remain in your fraction. So in other words, I have 2 wholes and then 2 elevenths left over. Okay, notice it's no surprise that it was 2 point something because the original problem was 2.18. Alright, so let's do one more. I think this one's the most challenging one, and then we're going to move on to something else. So if you could do this one, you could certainly do any that I would ever give you on your homework. Alright, so I'm not going to go through the steps this time. I'm just going to write down kind of, I am going to go through the steps. I'm just not going to label them step 1, step 2, and so forth. Notice the only thing repeating here is the 2, 5. The 3 is not repeating, so that makes this one a little bit trickier. But I still want a set of repeaters to be in front of the decimal place, so I'm still going to need to move the decimal 3 times. So that means I actually need to multiply by 1,000. Okay, 100 moves the decimal twice, 1,000 moves it 3 times. So if I multiply, so I'm going to rewrite this and give myself some space. So if I multiply this by 1,000 and also this by 1,000, then I'm going to get 1,000x equals, move the decimal place 3, so it'll be 2,325, but then it'll be 0.2525, right? I wrote that twice. We don't actually have to write it twice. But notice what happens here if I try to do the method normally. So notice that if we stack or try to combine 1,000x equals 2325.252525, and we try to line that up with our 2.32, do you notice that we're off? Okay. In other words, the numbers aren't lining up. Okay. So notice our decimal places don't line up here. But they're really close. Do you notice that they're 1 off? So if we could just change x up just a little bit and kind of shift that 3 over, then we would have it perfectly. So what can we do to our original that would shift the decimal place just 1 over? Okay, here's our original. Notice if I multiplied by 10, then that would essentially move the decimal 1 place, and then this would give me 23.25 with a bar. The goal of this is to not get something like this, where the decimals don't line up, but for them to actually work and line up. So in the end, maybe we could use this one and this one. Okay. Maybe we could line those 2 up, since those 2 are going to be the ones that match. So if you combine the circled equations, you're going to get 1,000x equals 2325.252525, ... I always tend to put 3 sets of repeaters. You don't have to do it that way. But we're going to line it up with the 10x instead of the original, because this is going to work out perfectly. Because this method doesn't work if you're not getting rid of the ugly repeating decimals. So now if we subtract those, and be careful, 1,000 minus 10 is 990. Okay, what happens to all the decimals just like we want? They're all going to cancel, right? And then 2325 take away 23 is 2302. And then last but not least, we'll divide by 990, and then we'll see, do we need to simplify or not? So we get x equals 2302 divided by 990. Now, notice they're both even numbers, so you can at least divide by 2. I think that might be the only thing we can do. So use a calculator, but if you divide by 2, you get 1151 on top and 495 on bottom. But again, that's an improper fraction. So over off to the side, you need to ask yourself, how many times can 495 go into 1151? And you don't need to think too hard about that. Look back at the original. The original was telling you what the whole number was going to be. It's going to be 2. So then 2 times 495 is 990. Notice we get a pretty large remainder. So this is my remainder. So in the end, it's going to be a whole number 2, and then your remainder over your original denominator. So that one's a little tricky. I feel like with some practice you can definitely do it. Okay, so let's look at, before we kind of end this decimal lesson, let's look at two common decimal operations and talk about how we do it. So how do we multiply decimals? And let's think of an example when we try to describe this. So let's think about 3.72 times 1.4. Okay, so how did we used to old school, before we had a chance to use calculators, how did we used to multiply this by hand? So you don't worry as much about the decimal places lining up when you're multiplying. But remember, you start here and you just multiply 4 times 1, 2, 3 things and see what happens. So 4 times 2 is 8. 4 times 7 is 28, right? So we're going to keep the 8 and then regroup the 2 there. And then 4 times 3 is 12, plus 2 is 14. And then hopefully you remember what you do here. When you move to the tens place, you put a 0 here. By the way, that's because whatever number's here is actually representing how many tens we have, so we need to move over a decimal place. So 1 times 2 is 2, 1 times 7 is 7, 1 times 3 is 3. And then you add whatever you get here. Notice I'm regrouping there, right? So 7 plus 4 plus 1 is 12. Regroup another 1 right there. So we end up getting 5208, right? But it's not 5,208, okay? I still need to account for my decimal places. So remember how you do that. You just count the total decimal places. And the total decimal places is 3. And then you include that many in the answer. So I'm going to say include that many places in the answer. So the answer is not 5,208. The answer is actually 5.208. So let's break down what we just did. So how do you multiply decimals? The first step we did is we multiply them as if they're whole numbers. We ignore the fact that they have decimals at all. That's the first step. Okay, remember that's the symbol for numbers in math. And then number 2 is you count the total decimal places and include that many in your answer. Okay. So in this class, I want to not only talk about how, but I want to talk about why, and that's probably a more important question. You as a teacher need to be able to answer questions like why. Okay, you need to understand it past the point of just copying because you watched somebody else do it. All right, so let's talk about how we can kind of show that. So we want to show why we're allowed to do the 2 steps we just mentioned. Okay, so first maybe let's rewrite these as fractions. So this would be 372 hundredths because we're in the second decimal place. And then 1.4 would be 14 tenths. And then how do we normally deal with fractions when we're multiplying them? We just multiply across the top and the bottom. So let's do that. So we're going to get 372 times 14 and then divided by 1,000. Okay. Notice I didn't work that out because I actually want to show this. Okay. I actually want to show what we're doing here. Notice this step will have us multiply as if they are whole numbers. That's exactly what multiplying the numerators will be. And notice the over 1,000 represents the fact that we have 3 total decimal places. So this is why that works. It works this way simply because of how we multiply fractions. All right, so let's talk about how do you divide decimals. For example, let's look at 3.92 divided by 1.2. So the first thing I just want us to work on is how do we do it, and then we'll talk about why we're allowed to do it. So the first thing is it is 3.92 divided by 1.2. That's the old school way to set that up. And how we deal with this, and I know it's been a little while for some of us, okay, but how we deal with this is we move the decimal place once here because it's easier to divide by a whole number than it is a decimal. But if I do that, I have to match that and move the decimal place the same way on the inside. So notice now my problem will be 39.2 divided by 12. That is an equivalent problem, but I think it's a little easier. So you put the decimal place here and you ask yourself, how many times does 12 go into 39? And the answer is 3. Notice it's not evenly though. 3 times 12 is 36. So this is what I meant when I said long division. So you're going to get 3 here. And then remember, you start this process where you bring down the next term and then you start it all over again. How many times does 12 go into 32? Twice. 2 times 12 is 24. So if you subtract there, you get 8. So we have a remainder, so what do we do now? Well, in a division problem with a decimal, we just keep adding zeros to the end until we maybe could see a pattern. Notice we're allowed to do that because it doesn't change the value of a decimal to add zeros at the end, right? So 12 goes into 80 6 times, right? 6 times 12 is 72. So 72 goes here. Notice I'm going to get another 8. So if I do this process again, hopefully you can see the pattern. You can see that we're just going to get another 6 here. In fact, we're going to keep getting 8s here and 6s up here. So let's talk about the answer and then we'll list out what we did. The answer then would be 3.26 where the 6 repeats. Notice only a bar around the 6 because the 2 is not repeating, it's the 6 that's repeating. All right, so first let's talk about what we did. We moved the decimal place on the outside until we are dividing by a whole number. And we match that on the inside, so I'm going to say do the same to the inside. Okay, we do that because it's easier to divide by 12 in this case than it is to try to divide by 1.2. Okay, so number 2 is you divide as usual. And that might involve adding zeros behind the decimal if you need to until you see a pattern. So that's the how, right? That's how we divide decimals. But just like with multiplication, I want you to know why this works. You know, have you ever asked a teacher why something is the way it is, especially in math, and they can't really answer you, or it seems like they give you just some answer that seems like they don't know? You don't want to be that teacher, okay? And you may be teaching fields that you're not really expecting, okay? So keep that in mind. So you want to be able to answer those questions. So notice I'm going to start with what I was given, right? I started with 3.92 divided by 1.2. What I'm trying to show is why am I allowed to change that to 39.2 divided by 12? Okay, so keep in mind what your goal is. So the first thing is, just like with multiplication, we'll set these up as fractions. 3.92 has 2 decimal places, so it's the hundredths place. 1.2 only has 1, so it's the tenths place. And then we can just divide across the top and the bottom. Okay, so notice what we're going to get here. We're going to get 392 divided by 12 over 10, because 100 divided by 10 is just 10. Notice this is not quite what we did. We didn't do 392 divided by 12. Okay, so we kind of need to change this just a bit. We need to figure out if we can talk about what we actually did. So a little tricky here. Notice, what did we actually do? Go back up here. We did 39.2 divided by 12. So what we can do is we can just put 392 over 10 and kind of pull the 12 off to the side. Okay, in other words, we have a single denominator, so we're allowed to do this. But then notice that this would just be 39.2. And notice this is it. Like this showed, I'm going to write end here to make a point. Notice I started with what I was given and I ended with the very thing that I changed it to. That was the point in showing why this works. Okay, so I'm going to have you try one of those on your own, just because the division ones can be different from each other. But before we do, I just want to reiterate that in our number system, when we move the decimal place, we're really just changing place value. So let's look at 3 problems that give us the exact same answer. 60 divided by 12 is 5. Okay. But if we move the decimal place in both of these numbers and we say 6 divided by 1.2, that's a harder question to answer. But if I said, how many $20s would it take for me to add up to $6, it would be 5, right? How many stacks of $1.20 would it take for me to get to $6? 5. And if I move the decimal place one more time and do 0.6 divided by 0.12, okay, so think of this as how many stacks of 12 cents would it take to make 60 cents? Notice I'm changing that to money because we relate to money a little bit better than just a regular decimal. So all of these give us the same result. Notice all we did was change the decimal place, right? So the place values change, but as long as we equally change them in both numbers, our answers don't. And also our digits don't. Digits meaning the 6 doesn't, the 5 answer doesn't, the 1 and the 2 don't. So the reason we do this method is it's a lot easier, it's a lot less brain straining, right, to do 60 divided by 12 than it is to do either one of these. Alright, so I want you to try 19.875 divided by 0.5. So I want you to do both the how and the why. So I want you to pause the video, see if you can kind of work on this. It's a little challenging, but I have no doubt you can do it, and especially the how. That's just old school division. So pause the video and see if you can do it. So how am I going to do 19.875 divided by 0.5? The first thing is, I'm not going to leave this as 0.5. I want to think of this as 5. So I can move the decimal place as long as I pair that with moving the decimal place there. So now I'm going to be doing 198.75 divided by 5. Okay, so let's go through the process. 5 goes into 19 3 times. 3 times 5 is 15. And then we subtract. And then remember, you bring down. So that 8 goes there, right? And then you ask yourself, how many times 5 goes into 48? And the answer is 9. By the way, the decimal place stays in the same spot. So 9 times 5 is 45. Next, we'll bring down the 7. So 5 goes into 37 7 times. 7 times 5 is 35. So if this part's troublesome for you, you need to go back and review just basic addition, because that's really something that we definitely should know how to do. And then 5 divided by 25 is finally just 5. Notice now we're going to get no remainder. Okay, so in this one I didn't even need to add zeros on the end, right? I was able to get an answer, a terminating decimal of 39.75. All right, so how did we just do that? So if I ask you to explain how, this is what I'm looking for. I'm looking for the steps, but also for you to describe what you did. We moved the decimal place once on the outside and inside. We did that so we would be dividing by a whole number. And then number 2, we just divide as usual. Once we've made the problem easier, we just divide as usual. So remember, I consider the y to be equally important, if not more so. So I like to do this because it kind of clearly says what I'm doing. Let's talk about what we're going to start with. We're going to start with what we were originally given. We were originally given this problem. So we're going to write that as 19,875. Pay attention to what place value you're at, right? The third decimal place, so that's the thousandths place. And then divided by 5 over 10. We're in the tenths place here. Okay, so now we can just divide across, just like you can multiply across, we can divide across. So let's talk about what we get. We get 19,875 divided by 5. And then on the bottom we get 100. So notice that is not quite what we should end with, right? We have to end with what we actually did, which is 198.75 divided by 5. So kind of like I did on the last one, I'm going to kind of move the 5 off to the side. Okay, so at least I have the divided by 5 part right. And then last but not least, I'm going to work out what this is. If I move the decimal place twice, this is literally 198.75 divided by 5. And the reason I know I can stop there is because that is actually what I did up here. So I could list the answer again, but I already found the answer in the how step. So I do think you're going to need to practice this for sure. Okay? Just make sure in these problems where I'm asking you how and why, that when you explain the how step, you're thorough. And when you explain the why step, that you look back at what you did and try to explain why you're allowed to do it.